Hello children, today we are going to discuss chapter 5, that is periodic classification of elements. What is this periodic classification of elements? The arrangement of elements into different groups on the basis of similarities in their properties. That is called classification of elements. The classification of similar elements into groups make the study of elements easy. There are about 114 different elements known so far. What is the case of the early attempts at the classification of elements? The earliest attempt of classification of elements was grouping then the known elements of about 30 into two groups that are called metals and non-metals. The defect of in this classification was that it had no place for metalloids. What are metalloids? The elements which have properties of both metals and non-metals and which were discovered later. First, we will discuss about Dobrinier's triads. Dobrenier classified elements in the increasing order of their atomic masses into groups of three elements. That's why this is known as triads. In each triad, the atomic mass of the middle element was approximately equal to the average atomic mass of other two elements. The defect of this classification was that all the known elements could not be correctly arranged into triads. Here, these are three elements in one place. These are three in one place, as well as these all are three in one place. Total three elements at one place. That's why these are known as triads. Now we will discuss about Newland's law of octaves. John Newland was an English scientist. He arranged the known elements in the order of increasing atomic masses and called it the law of octaves. It is known as Newland's law of octaves. What are the characteristics of the Newland's octave? It contains the elements from hydrogen to thorium, and the properties of every eighth element were similar to that of the first element. Suppose here, if we are taking lithium as a first element, then eighth is the sodium. Sodium is the eighth element. And if we are taking potassium as a first element, then Cu is the eighth element. So the property of first element is similar to the property of eighth element. That's why this law is known as octaves. The property of first element is same as the property of eighth element. Now, what are the limitations of Newland's law? The law was applicable to elements up to calcium and it contained only 56 elements. Further, it was assumed by Newland that only 56 elements existed in nature and no more elements would be discovered in future. In order to fit elements into the table, Newland adjusts two elements in the same slot and also put some unlike elements under same node. For example, cobalt and nickel are in the same slot and these are placed in same column as a fluorine, chlorine and bromine, which have very different properties than the cobalt and nickel. Same in the case of iron also. Iron, which resembles with the cobalt and nickel in the properties, has been placed differently away from these elements. So, what are the reasons behind this arrangement? He didn't speak anything about these statements. Now, Mendeleev's periodic law. What is this Mendeleev periodic law? Mendeleev's periodic law states that the properties of elements are a periodic function of their atomic masses. This is old periodic law. Here, atomic masses are in the increasing order. Mendeleev's periodic table. He classified elements in the increasing order of their atomic masses and similarities in their properties. Whatever we are discussing this time, this is the old periodic table. Okay. Modern In the modern periodic table, basis is only atomic numbers. So this one is the old periodic table. Mendeleev classified elements in the increasing order of their atomic masses and similarities in their properties. The formula of oxides and hydrides formed by the elements was also the basis for the classification of elements. In the Mendeleev periodic table, there are 6 horizontal rows that are periods and 8 vertical rows that are groups. In first to seventh group had two subgroups that are group A and group B. In eighth group had 3 rows of the elements. Elements having similar properties were placed in same group, and there are some spaces left vacant in the table to accommodate that the element to be discovered in future. What are the merits of the Mendeleev periodic table? Elements were classified on more fundamental basis, that is atomic mass and the properties. And the space were left vacant to accommodate the elements which will discover in future. It could predict the properties of the elements which will help in the discovery of new elements. The inert gas element discovered later could be placed separately in the group without any disturbance in the table. What are the demerits of the Mendeleev periodic table? Some elements are not arranged in the increasing order of their atomic masses, like cobalt. Cobalt is placed before the nickel, and Te is placed before the I. The position of hydrogen is not clear because it shows properties similar to the metals as well as non-metals. So the position of isotopes of the element is also not clear in the old periodic table. Now, modern periodic table. In the case of modern periodic table, Henry Moseley gave the new property of elements. What is that? That is atomic number. And this was adopted as the basis of modern periodic table. So in modern periodic table, elements are arranged in increasing atomic number. So what is the modern periodic law? The properties of elements are periodic function of their atomic numbers. And the position of elements in the periodic table is the modern periodic table consists of 18 groups and 7 periods. Elements present in any one group have the same number of valence electrons. And also the number of shells increases as we go down in the group. Elements present in any one period contain the same number of shells, also with the increase in atomic number by 1 unit on moving from left to right. The valence shell electrons increases by 1 unit. In each period marks a new electronic shell getting filled. This is the modern periodic table. These all are groups and these all are periods. Now from group 3 to group 12, whatever elements are there between group 3 to group 12, these all are known as transitional elements. Why these all are known as transitional elements? Because the shells are not totally filled. And these are lanthanide series and actinide series. In the modern periodic table, elements are arranged in increasing order of their atomic numbers in the form of table having 7 horizontal rows of elements that are known as periods and 18 vertical rows of the elements that are known as groups. So first we will discuss about the periods. There are 7 periods of the elements. In the first period, 2 elements are there, that from hydrogen to helium, and these are known as very short periods. In the second period, 8 elements are there from lithium to neon. This is known as short period. In the third period, 8 elements are there from sodium to argon. That is also known as short period. In fourth period, 18 elements are there from potassium to krypton. That is long periods. In fifth period, 18 elements are there from rubidium to xenon. That is long period. In sixth period, 32 elements are there from cesium to radon. That is very long periods. In the seventh period has 28 elements from francium to atomic number 114. That is called incomplete period. 14 element, each of the sixth and seventh period are placed separately at the bottom of the table. The 14 elements of the sixth period from lanthanum to lutetium, that are called lanthanide series, and the 14 elements from seventh period from AC to LR, that are known as actinide series. Now we will discuss about the groups. There are 18 groups from elements divided into 9 main groups. They are first, second, third, fourth, fifth, sixth, seventh, eighth, and zero group. The group first to 7 has 2 subgroups. Each are called group A as well as group B. In the 8th group has 3 rows of the elements, and the 0 group has 1 row of elements. The A subgroup elements are called normal elements. B subgroup elements are known as transitional elements. Lanthanide and actinide are called inner transition elements. Group 1 elements are called alkali metals. Group 2 elements are known as alkaline earth metal, and group 17 elements are called halogens. Group 18 are known as noble gas, as well as we can speak inert gas. In a group, all the elements have the same number of valence electron. In group first element have 1 valence electron, and group 2 element have 2 valence electron. Group 3 elements have 3 valence electron, and so on. In a periods, all the elements contain the same number of shells. Now we will discuss the properties of the elements in periods and groups. First, we will discuss about the valence electrons. See, in a period, the number of valence electron increases from 1 to 8, from left to right, and the number of shells is the same. For example, in second period, from element lithium to neon, these all are the atomic numbers, and these are electronic configuration. Number of valence electron, if we will see, then number of electrons are increasing continuously, and number of shells are constant in the case of valence electron in periods. Now we will discuss about the group. In the group, the number of valence electron is the same for all the elements, but the number of shell will increase from top to bottom. Like this is the atomic number. These are the electronic configuration, and valence electrons are same in the case of groups, but number of shells will increase continuously if we will move from top to bottom in the groups. Now valencies. In a periods, the valency of element increases from first to 4, then decreases from 4 to 0, from left to right. See, in the case of second period, if we will see from lithium to neon, then first valency will increase from first to 4, then it will decrease. So in the case of periods, first valency will increase, then valency will decrease. Now in the case of groups, in groups the valency is the same for all the elements of the group. Like, see, atomic number is this and valency is same in groups. Atomic size, in the periods, atomic size of element decreases from left to right because nuclear charge increases and so the electrons are pulled closer to the nucleus. In the second period, these are the elements and this is the electronic configuration. Number of protons are increasing. If number of protons will increase, then automatically atomic size will decrease in the case of periods. Now, in the case of groups, in group the atomic size of element increases from top to bottom because the number of shell increases and the distance between the nucleus and the shell will also increase. So, if we will see, then atomic size will decrease. Why? Because number of shells were, atomic size will increase. Why? Because number of shells are also increasing. This is the structure. If we will move sidewise, then we can see very clearly then size is decreasing. And if we will move from top to bottom, then this is also very clear, the size of atom is increasing. If we will move from top to bottom and if we will move from left to right, then size will decrease. Now, metallic properties. In the periods, the metallic properties of element decrease from left to right. This is the sodium, metal, sodium is a metal, magnesium is also metal, aluminium is also metal, but these are metalloids. Then these all are non-metals. So if we will move from left to right, then metallic properties will decrease in the periods. But in the groups, the metallic properties of elements will increase from top to bottom. See, these all are the, this is non-metal, this is metalloids, these are metalloids, and these both are metals. So if we will move from top to bottom, then metallic property will increase in groups. Non-metallic properties means electronegative nature and metallic properties means electropositive nature. In the case of electronegative nature, in periods the non-metallic properties of element increases from left to right. See, this is sodium. Sodium is a metal, magnesium is also metal, but these are non-metals. So when we will move from left to right, then non-metallic properties of elements will increase in the case of periods. But in the case of groups, the non-metallic property of element decrease from top to bottom. See, carbon is non-metal. This is silicon metal, germanium metal, silicon metalloid, germanium metalloid, and these both are metals. So if we will move from top to bottom, then non-metallic property of element will decrease and metallic property will increase. So dear children, this is the explanation of the chapter, that is periodic classification of an element. Thank you.